Alright, everybody, so, as you can see on the screen, there's already a lot of writing on it. I've already recorded this once, and this is actually the second lecture of today, that I've been recording today, that has died out. So rather than rewriting all of this stuff over again, I'm just going to walk us through it here sort of with a post-commentary kind of thing, rather than doing all of that over again. So this is section 8.1. It's talking about something called confidence intervals, and we're going to be working with confidence intervals for the next little bit. So we started off by doing this in general portion, which sort of defines how we're going to get a confidence interval, or what it means for it, more likely. Right? So in general, we're going to find a point estimate, which is always going to be something to do with a parameter. So it's going to be talking about X bar, or finding P hat, or finding S. It's going to be finding those sorts of things, which, as we talked about in the beginning of the semester, is a lot easier than finding population values, right? So finding population parameters. So we're going to find a point estimate of the thing that we care about. Then we're going to find a confidence interval, which is always going to look like that point estimate minus some number called E, and then this point estimate plus some number called E, right? And how we find that E differs depending on the specific case we're in, but it's always going to be one number that we need to find, and then we're going to subtract it and add it to our point estimate. And the other thing that we're always going to need is a confidence level, right? And then what that's going to mean for us, the reason we find that, is that the population parameter that we're estimating is always going to be, there's going to be a confidence level percentage that it will be inside the confidence interval. So that's a lot easier to parse when we have specific names of things that we're pointing at, and we've got a bunch of word problems. Well, we've got 3 word problems that we talk about, and we talk about specifically what this translates to in that case. But this is really the important part of confidence intervals, is what does it mean for us, right? So the particular situation that we're in this section is we are trying to figure out things about mu. That's the population parameter in question. The point estimate is X bar, right? It's the sample parameter that goes with mu is X bar. And for our purposes, we always want to know sigma, right? If we don't know the population standard deviation, we'll get into that in a couple of sections. We have to know an entirely new distribution for it. But for now, we're only going to be dealing with situations where we know what the population standard deviation is, and we also know that either n is bigger than 30 or the population is normal. And so if we're in that situation, the E that we were talking about up here is given by this formula. This is Z sub alpha over 2. It's what's called a critical value. Alpha is 1 minus the confidence level. And we find Z alpha over 2 from 3 different ways, right? 1, you can plug it into your calculator, the inverse norm that we've talked about before, and you put alpha over 2 in there, right? The other is you can find alpha over 2 in the center of the standard normal table, and then you look to the outer side to get your Z score, right? And so that answer is your Z sub alpha over 2. The other one is that our book actually specifically has a table of critical Z values. You can also probably find other tables of critical Z values, but table 8.1.1 is a nice reference to have to find these Z sub alphas. And that table just uses alpha itself, right? We still call it alpha over 2 because that's how you find it in these 2 situations. But the 8.1.1 table specifically looks at either the confidence level or alpha itself, right? And the last formula we have in this section is considering the fact that if we want a particular E, right, and usually we want that to be small, because it's that relates to how big our confidence interval is, and we really want our confidence interval to be small as possible. But if we want a particular E at a certain confidence level, then the only thing left to change is N, and luckily that's entirely within our grasp. That is entirely something that we can do. We get to decide what N is, because we are taking the sample, right? Remember, little n is always the sample size. We're the ones taking the sample, so we get to decide what it is, right? And the way that we do that is we take our critical value, which is, again, related to the confidence level. We already know what sigma is. There's a particular E that we want to hit, so we plug them into this formula, and then we round it up. And if we want, we can keep going up, right? So as we see in this next problem, we want to be 95% confident, right? So that tells us our confidence level, that our population mean is within 0.5 of x bar, right? That tells us our error, because our error is exactly how close are we going to be within or of our point estimate. So that tells us that our error is 0.5, and we have to be given sigma. There's no real, any problem from this section is just going to tell you what sigma is. There's no real way to hide it or gussy it up. Right, so our confidence level is 0.95, our E is 0.5, and our sigma is 5.6. So the first thing to do is to find the critical value here. And so we either take our alpha, I guess I didn't write it down here, but our alpha was 0.05, right, which is 1 minus 0.95. And so we either plug it into our calculator or we look at our table, and I looked at the table and I got that number, right? So we plug Z alpha over 2, right, that guy right there. We plug sigma, that guy right there. We plug N, that guy right there. Then we square it. And I threw all that into my calculator and I got this number. Our instructions say to round up. So we know that N has to be at least 482. If we liked nice super round numbers, maybe we would say N is 500. It's a nice, well divisible, lots of zeros number, so maybe it's a good one. But it has to be at least 482. All right, now we get into some word problems. So as we go through here, right, looking at this first sentence, the mean math score of students whose first language is English is 516. So that looks like it's important, but when we read forward, the next sentence is that a simple random sample of 20 students whose first language is not English. Right? So one of the things about the process of finding a confidence interval is that it's based entirely around sample data. Right? So whatever you have the sample data for, that's what you're making a confidence interval about. Right? So if you have any statements that don't refer to the population that you're taking a sample from, put those aside, put a pin in them, shelve them for later. You might need them, but you don't need them to construct the confidence interval, right? So that first sentence, we're going to table it, going to put it aside for now. But we have a random sample of 20 students, right? This right here is where we get N equals 20 from. The sample mean, as we see here, is 522. That's where we get X bar from. And population standard deviation is 144, and that's where we get sigma from. Right? And then this last sentence, construct a 95% confidence interval. That tells us that our confidence level is 0.95. So then we need to plug in for E. We have our formula here. We already found what Z alpha over 2 was for that confidence level, right? It's the exact same confidence level that we had before, so it's going to be the exact same critical value. But we plugged in our 144 and our 20. We threw that in a calculator. We got 63.1. We subtract that, or we plug into this formula here, right? Which means we subtract x bar and e. We add x bar and e, and we get these two guys. Now, the important thing about all these confidence intervals, right? All of these problems have a question. All three of these next problems have a question. But the most important thing to have stick in is that this confidence interval means that we are 95% certain, right? That's where our confidence level comes in, that the average of all students whose first language is not English, so that the population average of the population of students whose first language is not English is somewhere between these two numbers. Right? So that's what a confidence interval tells us. All of the questions that we might be asked just come from logically and grammatically from this statement right here, that we are 95% certain that the average of all students whose first language is not English is somewhere between 458.9 and 585.1. Right? Now, our question was, does that indicate that students whose first language is not English score differently on the math portion of the SAT? And if we look back to the first sentence, they mean differently from students whose first language is English, right? But what we can look at is, now's where we come back to that sentence that we had a pin in, right? The mean SAT math score of students whose first language is English is 516. Well, 516 is in between these two numbers, right? So we don't know the average of the students whose first language is not English, but we do know that it's in between these two numbers, and we know that the average score for those whose first language is English is also between those two numbers. So we don't have any evidence here that indicates that it's different, right? We haven't proved that it's the same, not by any means, right? There's a lot of space in between those two numbers that it could be, and it could very well be something different than 516. But nothing about what we found here gives us any indication that it is different, right? The only sort of clue that we have is they have at least one thing in common, that they're both between these two numbers, right? Okay, so the next question didn't have as much surrounding words. It was just sort of some values that were given. But one thing we notice is that this one tells us that the population is normally distributed, right? Remember, one of our requirements is that either the population is normally distributed or n is bigger than 30, right? In this case, we figure out that our sample size is 22, right? It just straight up tells it to us. So it's good that the population is normally distributed, otherwise this wouldn't be a problem in this section, right? It flat out tells us that sigma is 11, so we can just put that down. This statement right here again, right, this is telling us something about the population parameter and not about our sample data. So that's going to be one of those sentences that we need to put a pin in and maybe come back to later, right? But we already got our random sample size, and our sample mean, it flat out tells us that x bar is 76.9. Right, now we've got a 98% confidence interval, so our confidence level is 0.98, which tells us that alpha has to be 0.02, because remember, this is 1 minus 0.98. That's always how you get alpha. So again, the real thing that we have to figure out is our critical value, and we can either get it by plugging that into our calculator or by looking at the table. I got 2.33 by looking at that table that table 8.1.1, right? So then I threw this into a calculator and got 5.46. Now we got to throw that number that we got using a formula into a different formula. That's really all these problems are, is you've got a pair of formulas that you work out, and then you need to make sure you understand this conclusion, right? So we take our x bar and we subtract e, we take our x bar and we add e, and I threw it in my calculator to get that guy. So what this tells us is that we are 98% confident that mu, the population average, is somewhere between 71.44 and 82.36. We don't know where in between there, but it's somewhere in between there. Right? And excuse me. So the question here is, what does that tell you about your sample? Right? And again, this is where we come back to that sentence that we put a pin into it up here. Right? If mu is actually 80, right, that meshes, right? So 80 is between 71.4 and 82.36, right? So these two statements, right, mu is between these two numbers and mu is equal to 80, can both be true at the same time. Right, so that sort of tells me that my sample is a good indicative sample, right? It's a sample that is probably pretty close to telling me what the population is, right? So lastly, we were talking about the mean credit score of a credit union, right? So here, sampled the scores of 121 members. Right, so the members were clearly the population. So the minute it start talking about how many members it sampled, that's how we know what N is. Flat out tells us that the sample mean is 742.8. So one key thing about the language here, presume, right? So this says presume the standard deviation, or a standard deviation of 42.9. Right, now, just saying standard deviation, we don't know whether they mean S or sigma, right? It could be either. It could be the population or the sample. However, if they were trying to tell us what S was, we wouldn't have to presume that. We would know what S is, right? If we know what the X bar is, we know what S is, right? So the fact that they told us to presume, to guess, to assume, the standard deviation was something tells us that they are telling us what sigma is. Right? I had to correct a typo here because I realized that the table in the book didn't have the original value. So we're constructing a 99% confidence interval. So that tells us that we have a 0.99 confidence level. So we figured out what alpha was. We used that to figure out what our critical value was, and we plugged everything in, plugged it into our calculator, and got 10.04. We plugged that into the next formula, mu minus E, mu plus E, and got this interval, which tells us that we are 99% sure that the mean credit score for all members of this credit union is between 732.76 and 752.84. Right? So the question for this one is, if the national average credit score is 689.1, what does this tell you about credit union members? Right? So we don't know for certain what the average credit score is for this credit union, but we do know that it's somewhere in here. Right? And one thing we notice is that 689.1 is not in this interval, right? In the previous two problems, our sort of comparison value, the thing that we were comparing to, was inside the interval. But in this case, it's not, right? And in fact, it's specifically, this arrow is here because it's specifically less than that interval, right? So what this tells us is that while we don't know exactly what the mean credit score is, we are 99% certain that it is a higher average than the national average, right? So we are 99% certain that the members of that credit union have on average, higher credit score than the average American does, right? So, but again, this is the main statement. I had a lot of wigglies here because I just sat here and emphasized it a lot. But if you understand this statement that we have here, then all of the questions just sort of follow logically from that, right? So this sort of thing is the important takeaway from our confidence intervals. So like I mentioned at the beginning, our next sort of thing that we're going to want to do is to estimate mu when we don't know sigma. But in order to do that, we need a different distribution called the student's t distribution. And that will be what we talk about next time. So I'll see y'all then.